Let's just maybe think about um, maybe the efficiency of these two different ways of doing it. And kind of maybe show why it's not like that important to think about efficiency, or why like it's maybe on the lower end of things we care about. So if I look at so I have this number, this one way we did it without the reduce. So you can kind of think about like all of these functions, right, that we have to do, like especially like finding the lowest, finding the highest, finding the average, finding evens, finding odds. You can kind of think about like all of these operations. We're going to have to go through that array and perform an operation on each thing of that array, right? Like if I want to find the lowest thing, I have to go through each of my cards and check whether or not that card is lower than the one I have. So I'm going to have to do n operations for this. I'm going to have to do n operations for this one, n operations for this, right? So I'm going to have to like go through that list multiple times. And you might think that's like a lot worse than our reduce one, because my reduce one, I just go through once, right? I go through my array once and then I perform this function once. This function is doing more things, but I go through each thing of my array once. I check, is this divisible by 2, etc. Is it lower or higher? So, if I was looking at like kind of like the efficiency of this, or like how expensive is this function is going to, like, I don't know, if we're looking at that big O notation, this is going to be like 6 times n. Like this is how expensive it's going to be, where like n is the length of the array. So that's like a rough estimate on how many operations I'm going to have to do. Like an operation is, comparing if a number is greater than or less than a number, like how many functions I'm going to run. So I would say this is like 6n. But with big O notation, we don't care about this 6. Like this, we just considered like it an n operation. It's a linear operation. If I were to like draw that on a, let's just do some like quick little algebra. Right? If I have like my chart, like this is a n, like if you have like, what is it? Like f of x equals n. It looks like, and you do that on a graph, it would look like that, right? If it was like 6n, it's just going to change the slope. Or if it was like half, it would change the slope.
I can't see.
Yeah, it just started screen sharing.
Can you not see my whiteboard?
No.
Okay. Let me bring it back. Can you see it now?
Yeah.
Yes.
Okay, thank you. Right, does this ring a bell like back in algebra? Or like, this would be, n. This would be like 6n. This would be like, I don't know, half n. Like the number in front, if it's like a line graph, it's just going to affect, like the number in front of it just affects the slope. But with like big O notation, we don't care about the 6 or the half. We would just say it's n, meaning it's just linear. It's just going to grow linearly. We don't really care about the slope of it. Because what we care about like is, because if I have like a linear graph, it doesn't matter if it's like 6n or a half n compared to something that's like n squared. Like n squared is going to just like take off compared to the linear graph. Like it doesn't matter if this is like 200 n or 200,000 n, because n squared relative is going to like grow way faster once we get, once we start going bigger with our numbers at some point. Does that make sense? Like why they don't care about that leading number? It's more about the operation.
Makes sense.
Yeah. So, but yeah, just kind of like, so what I did, like, so this one would be like, this is just n, like just whatever, that's n operations. Same thing with this one, really, like that's just n. Because I go through my array once and do stuff. Here I go through my array like 6 times and do stuff. Cool. And just to kind of show you, I'm not saying like maybe one is more efficient than the other. Like I would say, yeah, this one probably is more efficient and we can, but the way to find out is to test it. So this is kind of what I did during break, is I created some tests to kind of time how long these take. So first of all, I just wrote a function that's going to give me a number string, and I can give it the size. And what it does is it just creates in an array. Like if I give this 1,000,000, it's going to go through, it's going to create in an array of like 1,000,000 things from 0 to 1,000,000. And then it creates that string. And then I can use, that function to create a big string. And then what I can do is I can loop through and run my function on that string like a certain amount of times. So I can do that test. And then what I'm also doing is I'm using this date class to get the time. So I'm getting my starting time, and then I'm going to, I'll say this like, it's like, this is like doing like a stopwatch. It's starting time. And I'm going to run tests. Then I'm going to get the time, like get end time, right? So what I can do, I can also like just loop over these tests. I can pass this, my function, like a really big string. So it has to do it like millions of times. And then I can like see how long it takes just by subtracting the ending time from the starting time. And then I can do the same thing with my other function. So here's all you have to really worry about now. So I have this test that's going to test the non-reduced way of doing this. And I'm giving this number of 1,000,000. So this is this is going to go through 1,000,000 things and test it. But then I can also give it this second number of like, hey, run this test like 50 times. So I can, does that make sense? I can run a test 50 times on a array or on a string that's going to eventually create an array of like 1,000,000 things. And I can test it for both functions. So let's maybe just do like once. Let's do like, so let's test this once. So on an array of like 1,000,000 things. How long do you think this is going to take? Like our functions that we wrote.
Quite a while.
Yeah, because it's got to do like, what we're going to do this like for like our find lowest, find highest, find average, for all of these things. Like we're going to go through each thing. That's going to be a million things I need to like compare. And it's going to be a million things I'm going to need to like reduce over, and a million things I'm going to need to map over. So yeah, there's quite a bit of operations. So let's just run this. So for my non-reduced way, it took, 1700 milliseconds. For my reduced way, it was 1300 milliseconds. So, and then we can kind of see how these grow. Like maybe I do this like 10 times. Like is one going to like insanely get like way more expensive than the other? Or are they going to like keep these ratios of like how much time they're taking? So let's do 10. And it seems like if I add 10, it's just going to take 10 times as long. So we're seeing that linear growth of these, like, it's not taking like, n squared more times. It's just taking n times longer. So if I do 100 on each one, like, I don't know, I probably expect this to take about 15 seconds and this to take about 12 seconds. Maybe that's just a rough guess. So there's our 15 seconds. And then this one, yeah, maybe around 12 seconds. There we go. So these functions are in, complexity. And because really, like, I think that's good. Like the difference between like 14 seconds and 12 seconds, that's not that huge deal. And like, as we go through and we make these more complex, like do more operations, we can kind of predict how much they're going to take. Like we saw with that one Fibonacci, that was like 2 to the n. Do you remember that one we did? That was like 2 to the n. And it's like we'd add one thing and it just like, the time it took just grew crazy. Like to the point where we were trying to figure out like the Fibonacci of like 56 and it'd like take the lifetime of the universe. It's probably more than that, but
Yeah.
But with n complexity, it's, they're going to, just grow like it's just going to grow like if I give it, 100, it's going to take 100 times. So, and these two, like there's really not much a like 14 seconds versus 12 seconds. Do I really care about that discrepancy? As long as these are both growing at the same rate, like this is why like we don't really like, that is like really nitpicky. So if you're like, well, this way is more efficient, it's like, dude, come on. It's not that big of a deal. Because what we're talking, like, I don't know, it depends how many times you're going to run it. Because maybe if I am going to run this thing like a million times, then maybe that gets into minutes. So, but if I just run this once, and this is on a big array, this is like a million things, we're talking a difference of 30 milliseconds. So. And then, yeah, if it's like 10,000, like if we make this smaller to like 10,000 and we do it once, like that's going to be sometimes, they can like pretty much be the same. 10,000 things is still a big number. Anyway, does that make sense? Is that kind of interesting to see that? I'll Slack out this if you want to look at that. All right, cool. So let's I kind of want to look like as a group. Let's go through your database design. I think, well, let me just go through, like, I just want to do a quick little spiel on this, and then I kind of want you to go through each of your database designs, and then so the other group can see it and just kind of look at it. But let me just kind of go over this. And so this might be like a little bit of a review, and then if we have time, we'll go through and we'll like, I kind of want to build out like an Amazon database, like a basic Amazon. So yeah, so just when we're looking at, building a new app, and we're kind of, especially if it's a web app, one of the things you're probably going to want to build is a database. And, we just briefly talk about this. So, but, some of the things we want to think about when we're building a database is the structure of it. Like, how are we going to organize our tables? Because there's kind of like this, what we want to do is create a database structure where we're eliminating redundant data. So we're saving disk space. So, and I kind of want to maybe show this in an example with like Lucidchart so we can visually see it. But you might, and maybe if I could, if we look at your database examples, I'll kind of like show what this means. But I kind of want to spend some time on this. So what does it mean to eliminate redundant data? We'll look at that in 1 second. We obviously want our data to be accurate and, kind of consistent. And we want ways to like access it. And we want to be able, like, in useful ways and easy ways to access it. So, because there's a couple ways we could technically, when we do a database, we could just have all of our information in one table. We could just have a master table that had all of our data in it. But that would make these 3 things very hard. Like, we would definitely have redundant data in there, which would make it hard to maintain that data. So think if you had like, so for example, think if you had like a username, like James Yates. You had like a last name and first name, James Yates, in your database. And that was me, but you had that in your database multiple times. That's going to be hard if, like, what if I update my name? You're going to have to edit it everywhere in your database, which would be a pain. So you would only want my name in your database once. And this is part of the reason, or this is the reason why we start to separate our data out into different tables and then associate them. I think this will be easier to look at in Lucidchart. Yeah, so before we start designing our database, and this is something you probably did yesterday, right, is you really thought about what you needed. Requirements to analyze, see the purpose of your database. You can organize that data into tables, and then you kind of think about what are the relationships between those things. So we'll do like an Amazon schema, or think if we're like trying to build out Amazon, or like, something like a public library, or some sort of like system where you had like customers and orders and products. You would think about like what kind of things you would want. So if I'm thinking about Amazon, I'm going to have like customers, and I'm going to have products. And so, a customer would have like a name, an address, it could have like which could be a city, state, and zip. And a customer could also have like an email address. Products could have a name, price, like quantity information. And then like a customer is going to go on the site and they're going to order stuff. So that'd be the ID, and just kind of order information. So let's just maybe go through and build this. I'll kind of do this a little more quick. Let's just go to Lucidchart and kind of build this out. Because I think when it comes to like database design, it's, for me, I know it's just so much easier to be visual about it. Okay. So yeah, if I was like doing a very a very simple online store, I might think of something like, I have like a customer. And then I would think about, what kind of fields does a customer have? Like, a name, city, etc. Like address. And I think, it'd be kind of easy to think, other fields we could add on a customer.
Would the customer have like a wallet too? Like where they store money?
If it was like Amazon, I would say that, I don't know. I don't know if you'd want to like store the credit card info, but they might have, let's just maybe think about that. They might, so we could just add that, like maybe our customer has many, payment options. Or maybe they have like many like cards, like bank cards or credit cards. Where a credit card could have like what's that thing called? The code? Is it just a number? The credit card number, like a CC, like having a stroke here. You have a credit card number and like
ACV.
Yeah, CCV. Is that what it is? So they'd have a number, the CCV, and like expiration date. I would just, so you would not want to store a credit card number in your database. You would encrypt it. But it would be like it'd be an encryption of the credit card number. But yeah, so I could have a customer have a credit card number, like many credit cards. So let me kind of look at this example. So kind of when I was talking about this, because this is a good example of this. So save days, we want to eliminate redundant data and maintain this integrity and data accuracy. Because you could ask yourself, well, why don't I just throw let's make this assumption that a customer can have many credit cards. So we'll just, on our app, we're going to say they can have different payment methods, which are going to be different credit cards. So they can have more than one. So you might ask, well, why don't I just, have a, customer table. This way. I'm going to do another customer. And have the credit, like this looks complicated, right? Like, why am I creating a whole nother table? I'm going to have to do joins and all this weird SQL stuff. Why don't I just have my customer table, have a name, have a whatever address, and all the other stuff, and then have like, just to keep it simple, have like a credit card number. Let's say that's all you need. Cool. Now I have all that information on my customer table, so I don't have to do any joins. I don't have to do any of that crazy SQL stuff. This is going to be easier to work with. right? Does that make sense? Like, oh, that's a good idea, right?
So you could do it either way.
Yeah, you could do it either way. Like either way would work, but this way would be like bad.
You said the right side would be bad.
Yeah, this would be the wrong way to do it. It actually caused you more trouble. Because let's think about it. Let's go like look at my database. Like let's go say, here's my name. Here's the address. So let's call this customer X, just so we can know what table this is. So here's like customer X data. So be name, address, and CC number. I think this is like, it's so hard to explain this without like just showing it. So let's say I have like, I'm a customer. So there we go, James. So I'm in this database. And my address is 123 San Diego. And my credit card number is 123456. And that's like, and we'll throw in a V there for my like Visa. Cool. But now I come in and I want to add another credit card number. What do I have to do? If this is how my table is.
I guess you'd have to create a whole new account.
Yeah, or I mean, I wouldn't have to create a new account. I could.
Would you have to do a whole new like credit card model? Because then you'd have user has many credit cards.
Well, so this one doesn't have any, this doesn't have any associations. So if I'm like,
Yeah.
and we could like hide this from the user, like I could just go in and like easily create a new credit card. We could like hide that from the user. So it's not like the user would know. But in my database, if I have a new credit card, what I'm going to have to copy this information, right? And there's my American Express. Is that, so now in this customer X table, I have this James information that lives and my address that lives in there twice. And there's the two credit card numbers. Because how else would I store this if this is my one table? Like, I couldn't do that, right? How do I know whose credit card this is and what's their address?
So that's why you just do a customer has many credit cards.
Yeah, because this would get messy really quick. Like think if like I wanted to update my address. And these would also have different IDs. Like you'd have customer X would be in here twice with two different IDs. Like, and now I want to go update my address. You'd have to go like, that could be challenging. You might not even be able to do it accurately. So yeah, that's why, I don't know, that's why this is like, no. This is why we have a different model, because let's call this customer,
So question, if they had a wallet and you wanted to keep track of how much money they have, would you also do that in credit card, or you could keep their wallet in their customer model?
I mean, a wallet, I don't know if it was like an account, it'd be like more like, yeah, wallet, just balance. I mean, that would be more like a bank. I don't think like Amazon, you would have like I guess you could maybe like deposit some money into your Amazon account, but that would just, yeah, that'd be like, that could maybe be inside of the customer. That could be like a balance if you wanted to have a balance. It would maybe, and you just have one account, like a customer has one balance. But I'm sure like this would probably be something, if you're doing something that complicated, you probably throw that into another table. But it depends. If it's just you want to keep track of one balance, like just if that's all it's ever going to be is one balance, then you could throw that in here.
All right.
Does that make like here I'm making like I'm saying that a customer can have many credit cards.
But a
So
customer really wouldn't have many balances because it's just one tied to the account. So I get what you mean.
well, no, you could, but like a bank, like because I could, but that would be like more like if I think like a better analogy would be like bank accounts. Like a customer could have many accounts. An account would have a balance. But if you just were going to have an app where a customer would always just have one account and could only have one balance, you might throw it on your customer table.
That makes sense.
So yeah. So now let's look at this, the better way to do this. So now, because this would be, does this make sense why I need to like throw in the user here twice if I do it this way? Like James is going to be in here twice. My address is going to be in there twice, but I will have the different numbers. But now I
Because-
have duplicate data.
Because if you didn't, the credit card would have nowhere to be stored to, right?
Yeah, it's like, how else would I do it? There's like no other way to do it if this is my one table. So yeah, what we do is we separate this data so we don't duplicate it, because now I can have a customer, A table. Now I don't need to be in there twice, and I don't, have the credit card number in there. I just have an ID. And there would be an ID in here too. It's not to say that this wouldn't have an ID. Like these would have IDs. One. But that's the annoying thing. It's like it's the same user, but they would have different ID, like it'd be two different things. But now because this, like my name and my address, assuming I only have one address, that's just for one user. But what I can do is then I can have a credit card table. Let's do it with this one. So that can have like the CC number, which could be, let's just copy this one. And let's copy that one. So then I can store these two numbers on here. And then I can have the customer A underscore ID. Just keep track of that number. So now if I update James to like James Yo, like that's good. I only need to update that one place or the address. That's why we break these up into their own tables, because now when I'm storing this information, I'm only storing it once. But we have these associations by throwing the ID in here. I know who this belongs to because I have their ID. I know whose credit card this belongs to because it belongs to the user, the customer A who has ID 1. Well, I can go to my customer A table and look up that ID. That's James. Does that kind of make sense? So
Yeah.
That's one of the things we try to do there. So let's throw that aside. Okay, so let's keep going with like Amazon. So yeah, something else we might have is products. We'll just keep this simple. Like a product has a name and a price. It could have a lot of other things, but we can just keep it like that. I'm just going to call this customer. Now, since you kind of did this, remember how you had categories in your products table? That's probably not the best way to do that. You remember how you store categories as like text? Why would that maybe, let's think about why that's actually kind of not a good idea. Do you remember what I mean? Like in your homework, you had categories, etc., and we stored that as text.
Yeah, I remember that.
Okay, so let's maybe look at why that is not maybe ideal. It worked, but let's maybe look at why that was not, that could not be good. So let's say I come back here and just, I think it's best, once again, just to kind of look at this with real data or some like fake data. So let's just assume here's what your database looks like. You have like your name. I don't know, like you could have like headphone. Just like looking around my desk to think of stuff. And you know, coffee mug and like a mug. So there's some products. And then let's say they have like categories. And this one, you know, might have like, since this is a string, music, sound, I don't know. Cool. There's the categories. I mean, these are just random. Let's just do music and sound. Who cares? Music, sound. And then here, let's say mug. That's like drink. I don't know if beverage. I guess like beverage. And you know, coffee.
You instead do this in SQL, right?
What?
Like last time for the Etsy project, you kind of did cities. Well, we did categories, but you did cities, but you kind of can do that in the SQL, right? To kind of group them together.
Well, I mean, they're both. I mean, it doesn't like, this is just how we're setting up our database. We can use SQL for either way. This is more like database design. So
You said this is bad though to use categories?
it's bad to use categories as a text in your products.
Oh, okay. I see what you mean now.
Which is how we did it. It worked. But let's maybe think why. So in that, okay, I'm just gonna say special. Just kind of trying to make this a little more simple. Okay, special. So let me ask you this question. And this is, I only have two things in here, but let's say like for my website, I want a page that lists all of my categories from all of my available categories. What do I have to do?
You have to go through every one of those tables that has categories, right? Should be getting all the other information too.
Yeah, I go through all of, I would have to go through all of my rows in my products. I would have to go through and get all of the categories. So get all the categories, you know, go filter them and like make them so they're unique. And yeah, that might be a pain. Like, and then also I'm having duplicate data once again. Like maybe I have a category of things that are on special. So this duplicate data, like it's kind of like I'm going to have like this string. You can think of this as like taking up space in your database, like this special word, you know, it's a certain amount of bytes. It's going to be taking up, you know, if it's in my database 10 million times, it's the word special because I have 100 million products and 10 million of them are on special. Like that's going to be in my database 10 million times. So that's like 10 million times whatever bytes of, you know, duplicate data. Right? You see how special could be in here multiple times. Music could be in here multiple times. Because let's say I only have like 20 categories, but I have, you know, 2 million products. There's going to be a lot of duplicate data, right? And then there's going to be a lot of work I have to do to go in and to find like those unique categories. Because they're all like hidden in strings. So I'm going to have to like take those 2 million strings and like that's like the brain teaser. It's like, okay, take these 2 million strings and give me back all the unique values. So that's probably going to be an expensive operation, right? Yes, no. Does that make sense? It would work. It's not like this one would work. Like you can get this to work. It's not like it's going to break your code. This one would like potentially, the one we're doing with like the customers, this one like would be hard, really hard to maintain. Like I don't know how this one would be dangerous. This one would work, but it's getting to that, like it is inefficient. It's not maintaining this, you know, this way to access this data. Like it's going to make it more challenging. We're going to have redundant data. Can you see that? Like, let's say I have a mug and then instead of a mug, I have like, you know, mug 1. That has the exact same thing. And then also you can maybe like get into like maybe cases where, you know, maybe you're misspelling stuff. Like it's really the same thing, but it's like misspelled or it's like a different twist on it. And then you kind of get like the duplicate but not duplicate categories. So what would be a better way to do categories for your
Separate
product
model,
What?
just a separate model.
Yeah. So here we go. Here's our categories.
So it'd be categories has many products or products has many categories?
You tell me. What does
I'd
it say?
Categories has many products.
Category has many products, but what if a product has many categories?
So then it'd be product has many categories. Wait,
what do we need to do here? What's the association we use for this one?
this one slightly confuses me a little.
Has many through.
Yeah, this is the has many through, or the many to many. So what we do for because a product has many categories and a category has many products, right? I mean, the way I could say a product only has one category, but that's not true. Like products could have multiple categories. So what I need to do here is I come up with this association where they have many of each other. So it's a many to many. And how I do this in my database is I need another table. So I need a products or product categories table. This is where like the intuition of like the mental model kind of breaks down. Like it's just, yeah, I need a table to join these two things. And how this really joins it is it just keeps track of the IDs. So it's going to have a product ID. And then that's going to be, that's going to be the foreign key. That's going to be the ID of our product. And then we're going to have a category ID. Bigger. And once again, that's going to be the foreign key. And that's really all we could add, maybe add some more stuff, but I don't really can't even think of anything we would throw into this table. But that's how we can associate these two tables. So if I were to look at this as like, actual data. So let's get rid of the category here in our product, because now that's no longer there. Cool. So there's our product table. There would be some of the information. And just so we can see it, let's give this like an ID. 23344. So headphones have, ID 22, mug has an ID of 33, mug 1 has an ID of 44. Then we could have category, our categories table. That could have a name, so that would be like music. Then we had like a beverage one, beverage. And special.
And special, you're referencing what again?
Special is just, it's the name of the category. It's just special.
Okay.
Like I could have give me all the music categories, give me all the beverage categories. Maybe special could be things that are on special.
Okay.
It's just a made up thing. Cool. So now those they just have a name of what the category is and then an ID. So same thing with my products, a name of what the product is and then an ID. So then in the join table, like the products category. So like this is where I keep track of like what belongs to what. And this is how I can do the many to many. So I could have a, product ID right here. Spelling this wrong, but category ID. So my product, so I'm doing my headphone. That can be in here multiple times. 1, 3. Let's just do some more. Then I could have like my mug in here. That could be the beverage. My mug can be in there again.
So that's like having your headphone in the music category and then also in the special category.
Yeah, exactly. So my headphone, has a category of music. My headphone has a category of special. My mug has a category of beverage and my mug has a category of special. See, so here I'm just keeping track of the IDs. So now I'm not going to have, once again, now I've eliminated that redundant data. And now, like, if I want to go get all my categories, that's really easy now, right? I just go category.all and that's going to be really quick. Because I only have 3 of them and they're nicely in their own table. Same thing with my products. They're kind of their own things, but I can create the association with them by just keeping track of the IDs. So this way it's like I can associate them back together. This is where I can do my joins and my SQL. So, hey, give me this category, the one with 3. Okay, that is the special category. And give me, like I could say, hey, go through my product categories and bring back all of the ones who category ID is 3. So that would give me all the IDs that have of the products who category ID were 3. And then I could go grab all the products who were on special. And I'm not duplicating data. It's going to make things quicker because now instead of having like, all these copies of all these same categories, they're just going to be in there once.
So will you still have that categories attribute on that products model?
Nope, that takes that away.
Okay.
Yeah, thank you. So now that's gone because now that's its own separate thing. Cool. So yeah, now we have our customer. Our customer has like our credit card belongs to a customer, right? That's like the one to many. It doesn't make sense for a credit card. I guess you can have like, people will share credit cards, like, spouses might do that. But I think, in like a website, you probably wouldn't have that be the case. I don't know if there's a website where you like log in. Is there like shared login websites? I don't think there are. Anyway, so this would make sense for our credit card belongs to just one user in our app. But like our products can have many categories and our categories can have many products. Okay, so let's maybe now think about what's the association, because this is kind of close now. What's the association between our customer and our products? Or like, this one gets a little more tricky. Can anyone like, there's actually probably one more table or two. Does a customer really have many products? What you do when you go to Amazon, you go like buy stuff, but you can do that multiple times, right? It's not like you just go buy something once. What you generally do. Like go shopping, you have maybe like this concept of like a cart or an order, right? This one's a little more like, I think this is a little more not tricky, but like maybe hard to like say, but then once you see, like once you say it, it makes sense. So a customer is going to have many orders. Does that kind of help bridge the gap? So an order might have like a, I don't know, like a date. It might have a, shipping address.
And then would it have many products?
Yes, and then that would have many products.
But only one buyer or one customer, right?
But yeah, but what about, do products only have one order?
No.
No, so an order can have many products, but a products can have many orders. So then we need another join table for this. So let's maybe just, and then this will kind of be like the end of this. So let's do one other like just to kind of show, like here we have like our two keys that maybe don't need any information associated with it, but I think when we look at the product and orders, I think we can maybe think of some things that might be a little different with this. So, or things we could add to this. So something I'm going to do like is for my products, I'm going to do like a retail price. So I could have a product that has a retail price, but sometimes you buy a product and it's not always the retail price, like the price can change. So how would we solve that? Like, these are the kind of things we think about. We can't, I'm getting my max. Okay, I'm just gonna go delete some of this. So these are kind of the things we think about when we're like designing our database. It's like, doesn't that make sense, right? Our product, like, let's say I have, you know, my headphones. They retail for $20, but you know, it's very common for things to go on sale and they are actually, you know, $15 or $12. Like the price can change. So on my products, I might have that have like a retail price. But then I'm going to create like this product orders table. So this is going to have like the order ID.
So just a question then, what is the price and what's the difference between price and retail price on products?
Well, this is that's just like retail price is like, what should this product sell for?
And then
It's
what is
like-
price?
What is, then I'm going to have another one like price or sell price, or what's a better word for that? This is the price that the person actually bought it for.
Sold for price.
Purchase price,
Sold price?
probably.
I like, yeah, purchase price. That's purchase price. We have our retail price and then what you actually paid for it. So we'd have our order ID, product ID, purchase price. You know, we could also maybe in here, I just want a row. Give me a row. You could maybe even have like a quantity on here. Like how many of these for this, or like, you know, actually let's do this. Like how many of these did I order? Like, you know, I'm James, I'm doing an order. I go buy a headphone who's selling for $20. I buy 3 of them. I buy 3 of them for, you know, $10. So that's how maybe you could kind of keep track of that. But there's like a little, like, no, do not leave. Okay, I guess it wanted to leave anyway. Hopefully that's saved. Here's like our little Amazon app. But can you kind of see how this works? Like a customer has, and we could go and make more attributes, but we have a customer. Our customer is going to have many credit cards. A customer could have many orders. What does an order comprise of? An order is going to comprise of product orders. We're going to have the product ID, how much it was actually sold for, and how many of them were bought. Right? Because I could, then our products are going to have many categories. Our categories have many products. You see how like we could build like a pretty decent like online store with this database design. But does this kind of also show like, you know, we're creating this in a way, we're not going to duplicate any data, right? Like we built this in a way where I'm not going to have a credit card number in here twice. I'm not going to have a shipping address in here twice. I'm not going to have, well, I could, actually the address might be something I could maybe throw off into a different table. Right.
So you'd create 7 different models in the backend with how your chart looks right now.
Yeah. The address I might want to throw off into another table. Like a customer has one address, and then this would be like well, I don't know. I think like a shipping address, if I was thinking about it, might be fine just to leave random, right? Because sometimes you can, you might not store that in the database. Because like I'm somewhere new, and I just did an order. I'm like, hey, mail it to this address. That was part of the order. Like it wasn't part of my customer information.
Yeah, you usually have a shipping address and a billing address.
Yeah. But also an order doesn't have to have, like an order doesn't need to be one shipping address. Like that's right. I could have a shipping address, but I also might want to have them ship to something that's not my shipping address or my mailing address. It's kind of things like I just bought glasses from Zenny. It's like, and I bought them in San Diego. It's like they're not storing my, it's not like I have I have a billing address with them. And they might say, hey, do you want to ship this to your billing address? But they also give you an option, where do you want this to ship to? It's like, I don't even need to tell them. So I don't know, maybe behind the scenes, they like throw that address somewhere and like do it, but that's what they might do. Like a customer has many addresses and then throw that there. That's probably what they do. But behind the scenes, when like I created that new address, they probably might have just thrown that into. But like as a user, I didn't. It's not like I created a new address. So that might look something like this, where if we wanted to handle multiple addresses, like a customer could have many addresses. And then it could also maybe have like a type. Nope. Billing, shipping. And then you could have like all your other stuff like city, street, etc. And this shipping address would be address ID.
And then that address ID in the order would be a foreign key.
Yeah, that'd be a foreign key. But there can be those things where like it's do you want your customer to have many addresses? So that could maybe be a way to think of that. What else could our order have? Order date. Yeah, this might have like a status, like is it sent? Is it in transit? Stuff like that. We remove this from here. And this would have an address would need to have then. The one thing this would have to have, if this belongs to it, would need a customer ID.
Kind of just a random question, since it's kind of related to this. How long do you think it would take to make an e-commerce website front end and back end?
Well, I mean, depends. It's this part, the back end's not hard. This back end would not be that hard to make. But yeah, if you actually want to start hooking it up to money things, I mean, there's third-party libraries, but yeah, I don't think it'd be that much work. But it's once you start working with money, you're gonna want to like the work's gonna be making sure it's not buggy. So you don't want to like do a buggy e-commerce app. And then the e-commerce thing, like you get into like shipping and billing, that like how do you ship stuff? E-commerce can be hard because it's like there's a lot of like non-code associated with it, right? You remember like Amazon first came out, like you would like put up your books for sale and then you would have to go to like to like UPS and go ship them. So they've streamlined a lot of that, but
Yeah, I was just curious, just because kind of that's kind of like how you're making it right now, kind of the e-commerce. So
yeah, I mean this would give us a like this is this is pretty. I mean, it's simple, but like this would give us at least the back end to do like a basic e-commerce app, right? I mean, there's details like this credit card stuff, like encrypting, actually getting the payments. The hard part, I think, is like the actual billing and like shipping of stuff. Because then you gotta like think, well, it's like, is the customer like, if it's just you doing the shipping and you're like a trusted company, like if I was like, I don't know, like a pizza shop, and like I'm creating the products and people order online, but I don't know. It's a little more complicated to actually make it, I'd say, functional. But yeah, I don't know, if you had your own little business, I think this could maybe, this would get you close. Yeah, I don't know, was this helpful? Do you want to, we don't have that much time, but do you want to share does someone from each group want to take like 5 minutes, share your Lucidchart?
yeah, it was helpful to me, and I think yeah, that would also help if we share ours.
I have mine pulled up right now. I can
Cool.
share real quick.
Yeah, you want to show it?
Okay, can you see that?
Yeah. So yeah, Ian, like I want like the other group, like just take a second, like you might not know what their app is that well, but I think if you take a second and you just kind of look at the diagram, you can really kind of see what the app is doing or what it might be able to do. So like I look at this, it's like, okay, a user has many campaigns and a user has many. So something I'm confused about right now is what's the association between campaigns and posts and users?
Posts.
Is it a has many or is it, it's a many to many, right?
Yeah. So it's like a campaign can have many posts. This one, it was a little confusing. We just did it based off our Figma. But it's basically, I think it's basically just like a comment that a user can leave on a campaign.
Yeah, so like when we have a campaign, the person who did the campaign on the right side, they can do an update. And then any person who's a user, they can make comments at the bottom and just like wish good things like, oh, prayers to them, or oh, I hope your business does good. So you don't even have to donate, but you can also just make a post in the comments and people can like it and they could like it too.
So a user has many campaigns and a campaign has many users.
Yes.
But so
No, a campaign would have one user, no?
Yeah. Campaign has one user.
A campaign has one.
So it would be the person who created the campaign.
Because multiple people couldn't interfere with that one campaign. It's just they can donate to it and everything, but the one person who makes the campaign, it's tied just to him.
Oh, okay. I think I can. And then like, so a user creates a post.
Yeah, under the campaign.
Okay.
Maybe it'd be helpful if you saw the grayscale too.
Yeah, you want me to?
Yeah, I would make, but I think there's this like I see. Okay. Let's just keep it at the wireframe though. It's because the gray, like the wireframes are like I'd say the models are more powerful because it's like you come up with a model, you can like, or database diagram, you can think of just multiple ways of how to do the UX for it. So, and then so a donation, so a user, I almost think you don't need, I'm trying to think of these like have many, I know they're like associated. So campaign has many users. Are you doing like the through?
Well, it's because I don't think a campaign does have many users. Like users as in if people want to post, yes, but users, like only one person can make that campaign, but multiple people can donate to that campaign.
Yeah, campaign has many donors, not users. Kind of different. Each user is one
But a
donor.
user can have many donations too.
And a user can also have many posts under campaigns.
Yeah, so the donation, like a campaign can have many users through donations and can have many, a user can have many, because a user can donate to many campaigns and a campaign can be donated by many users. So,
Yes.
so the donations make sense. I'm just this post one. I
It's
don't
more
know.
like I feel like a better word for this would be like comment
Comment.
and then like a description or something. I don't know.
Yeah, because basically anyone who has an account with We Care can go to any campaign and they see a business that they like and they'll be like, oh, I hope you're
Yeah.
doing good.
Okay, I think that. But like, I see how a user could comment on many campaigns, but a campaign, a comment's just really going to belong to like a campaign. I mean, I get why it belongs
But
to.
then how would that be associated to the user?
Because a user would have to have an account to.
No, I guess, no, you're right, because a user can comment on many campaigns and a campaign can have many comments from many users. Yeah, that's good.
Okay.
And then, so your user can have many like credit cards. Is that kind of what you're thinking?
Yeah, I kind of just threw this together just barely.
Or
But yeah, this would be like their wallet or credit card. Like we haven't talked about this yet, but
Because I mean, technically though, too, when you do log into websites, you can have multiple credit cards because they do save it.
yeah, I don't know. For this, you might not even want to like, you might not even need to save the credit card. Just go in, you enter it, and you're done with it. So you might not
I
even.
think that was part of our Figma that Will had us do. Like just to have a wallet
Okay,
feature.
cool. That works. And then, so your campaign has many, we just looked at the categories one.
Yeah, it's the same thing pretty much.
And then what's the campaign has many, what's that? Like photo, what's this one?
This update, this is, I can just show you here.
No, you're right. That one pitch. Yeah.
Okay, yeah. So it's like updates on the campaign, like kind of just
Oh.
how it's going.
Okay,
And then like if they wanted to take a picture of the progress that they've made with the donations or whatever, they can insert it right there.
cool. Yeah, I think, yeah, that. I
Is
think
there
that,
anything else we need?
no, I think you're good.
Okay, cool.
Thank
Sweet.
you.
Yeah, thanks.
Sweet. That looks good. I mean, there might be minor tweaks we make, but I think over, like the thing I'm more important, like I'm more worried about or the thing I look at more is I'm more like looking at the associations.
Yeah, for sure.
That's like more important because like adding and removing attributes, that's easy. It's like the associations that are, and it's not to say you're going to get them right. You might change those later on, but the better we get those, the less consequences.
By associations, that's the foreign keys and like the belongs to.
Yeah, that's like the one to many and the has many. Yeah, it's like how the tables relate to each other.
All right.
I kind of like how you said that a user has like many donations through campaigns or something. Should we do that?
No, that's how you have it set.
Oh, it is how-
Yeah, that's how it is.
Yeah. That's like the Rails way of saying it.
yeah.
Yeah. Cool. All right. What about the other group, fresh potatoes?
I have a quick question for them.
Yeah.
Is it in your like instructions that you have anyone can comment? Because it might be better if you just only allow the people who donate to comment.
Yeah, I was thinking about that.
Just a thought.
Cause yeah, we're trying to decide right now, because how we do have it, just anyone can go under that specific post and like comment under it, but you have to have an account and be a user. But
I just imagine like bad actors coming along and being like, "This is so dumb. Why would I donate to this?" And be
Yeah.
like,
I like the idea of not being able to leave a comment unless you've donated.
Yeah,
Don't worry about trolls.
but also it's like,
The world of trolls.
yeah,
yeah, we'll have to take that into consideration. Definitely.
I was thinking about that. It might be a way to help get more donations too, honestly.
anyway, sorry, on to us.
But yeah, definitely good input.
Or take the constructive criticism.
Yes. Someone from Fresh Potatoes want to share? But yeah, we will have like before the last week, we'll have each groups test the other group's app, and it's kind of nice because you get like a fresh pair of eyes. Because once you start working on something for like a long time, you just don't see something that's like right in front of you. So it's good to get that fresh pair of eyes.
Anyway, I guess I'll pull it up.
Yeah, I don't mind talking if someone else can share because
Oh.
I'm kind of in a car.
I'll share. Okay. Where are we? Oh, yeah, right here. Okay. Sorry, I don't know how to work Lucidchart very well yet, but okay. Are you able to talk, Jess? You can if you want.
Yeah.
Too.
Either way.
Okay. So go for it.
So our kind of main so we have an image for the poster, plot synopsis, and then the video is the trailer. Oh, can you not hear me?
Yeah, you're slightly cutting out, at least on my end.
Okay, then probably not me talk.
I can let me. Can you like zoom out a little?
Yes. How do I do that? That's where,
Maybe command minus. Will that do it?
oh yeah, command. Let me check.
Bottom right of the
There you go.
page.
You can just use
down
your,
with the plus and
fingers.
minus too.
What would you guys say?
The bottom right on the page, on the page that you're on, there's a
Oh,
plus
okay.
and minus. Zoom in,
Thank
zoom
you.
out.
Okay. So let's see. Okay, so you have a user model that's going to have many reviews.
Yep.
And then you have a movie. So who creates a movie?
Oh yeah. We had an
Admin. There's gonna be an admin side to create movies.
Oh yeah, the admin.
So, but who's
Only
the
admins can create movies.
okay? But an admin's going to be a user, though, right?
yes.
So on your user table, you are probably going to have like a role column.
Okay.
So like it could be just like a normal user, or it could be an admin.
Okay. I'll make a note of that here. Okay.
So then, yeah, users going to, oh wait, you have this role. Oh, sorry, I didn't scroll up. You have the role right there.
No, that's a little different. That's for our cast and crew of the movie. So it's not quite the same as the user. Maybe it can be the same.
Oh, a movie has many
In the
casts.
movie, the people in the movie have roles.
What would be
Like a
what would be a
director,
role?
A director, the actor.
Okay. Cool. I see what you're saying. Okay, so then yeah, I would on your
User.
so your movies. So your movies has many casts and crew through roles, and your cast and crews have many roles or have many movies through roles. Okay. Because yeah, you could be like a Tom Cruise and you could be in a movie as an actor, or you could be Tom Cruise, you could be in another movie as a director, right?
Right.
Tom
Yeah.
Cruise.
Yeah.
I was gonna say for some reason like Alec Baldwin was the first person that popped in my mind. I was like, oh,
It's
no,
like
no.
everyone always talks about Tom Cruise. It's just funny.
So yeah, so then a user would have many movies.
Oh, yeah, especially in the case that you were talking about where we need to have like the admin person.
Yeah, but you're just gonna have it only if that role is admin. Can a user create a movie?
Got it. Okay.
And then a movie can have, or a user can have like a review. Yeah, so you would review a movie with a user ID and a movie ID. That works. Okay, cool. Yeah. So I would just have the user ID in your movie table.
The user ID in our movie table. Okay. Got
Yeah.
it.
Just so you know what admin created that movie.
Yeah.
Cool. Wait, what did we just do? Which one?
We're adding a user ID foreign key to your movie table.
Okay.
Because I'm assuming like you're going to log in as a user. Maybe if you're an admin, then you'll have the option to create a movie. But if you're not an admin, you can go in, log in, and create like a review. Right?
Yep. Yep.
I have a question. So video, that's like a little short summary, I forget what it's called, of the movie.
It is a video, like a video,
Yeah,
like
it will be a
a
link.
trailer.
Like, yeah, trailer, that's the word. That's like trailer, right?
Yeah.
Okay.
So the movie or the user ID and review won't conflict with the user ID for the user, right?
The user ID for the movie won't conflict with the user ID for the review.
Yeah, when it's linking to the actual user, because it goes to the user, the review, and the review to the movie.
It's more of, if I was looking at one review entry in your database, I would see like the user ID 1, movie ID 1. I would know user 1 wrote this review for movie ID 1.
Okay.
If I saw user ID 1 in your movies table, I'd be like, oh, that's the user who created this movie.
Okay.
So like the user could be in both tables, but it's just what it means is different. Does that make sense?
Yeah, that makes sense.
Yeah.
So if we eventually connected this to an API to pull the movies from like an API, how would that affect like the user ID in that table?
If you did that, you might, you could maybe like create a user in your database to handle that, like just so you would know that like those movies were. Well, first of all, if you're pulling the movies from an API, you're not going to store them in your database, right? Because you're pulling them from someone else's database. Does that make sense?
Yep.
You could pull from someone's API, create like maybe a API user, and then store them to your own database. But yeah, I think part of the point of using an API is like you don't need to grab those from your own database. Cool. Yeah, cool. You're doing some stuff with roles. That'll be fun.
Hey, real quick, if you're done, can I just see your guys' Figma real quick? Like just how your kind of little design is gonna look compared to ours.
Let me just say, it was just, and then yes, Randy, let me just say one thing though, before I don't know if like Michael has told you this, or I just want to make sure. So when you're storing an image or a video, what we're going to be storing is a URL to like, to where that image lives. Because have you ever gone online and you can go like open image in a new tab and it gives you a URL?
So kind of like an HTTP request.
Yeah. So that's so those are good. And because we'll talk about image upload next week. I just want to make sure you understand that that's what we're storing for our images is going to be a URL, which is going to be a string.
Okay, cool. Yeah.
Cool.
And then our Figma you wanted to see, our wireframes are here. Let's see, let me zoom in. There we go. So this will be like a carousel with movies. You can like swipe, kind of like Netflix. Let's see. Here's our like review part where you'll have like the trailer, poster. This is where they give their rating and they can write their review, then info about it, cast and crew down here. I can't remember what this is.
I think he just added that because I wasn't there yesterday.
I think that's
That looks like your movie category.
Okay, yeah, I was like, my mind's going blank. I don't know what that is. Okay, and this is just like their profile. So that's it so far.
Does that like look like a categories? If you scroll down, that you have a categories feature down there? Maybe. Yeah, we might need.
Yeah, it says comedy animation.
we have genre.
Oh, wait, go back to your Lucidchart.
On our movies, we have
Oh,
genre.
okay. So a movie. Okay, so a movie would have one. Okay, that's fine. So it'll kind of be like, if you just have one genre, then you could throw it on the table. If you wanted to handle more than one genre, then you'd kind of do what we did in the categories.
Oh yes. Oh yeah. Okay, and we might want to because there's.
So
some
you
that are,
might
like,
want to do that. You might think about that.
Yeah.
Something to think about. So, but
Yeah.
overall, I think it's looking good.
Okay, cool. Thanks.
Cool. Yeah. Well, let's take lunch. Let's come back at 2:15 and go from there.
Sounds good.
Cool.
Sounds good.
Thanks, James.
Yep. Have a good one.
Thank you.